Hey, I'm Mrs.Compile, and today we are going to break down HTTP, the conversation your browser has with every server. No boring lectures, just how it actually works. So, let's get into it. Last episode, we figured out how your browser finds the address of a website. DNS does the detective work, hands over the IP address. And your browser is like, brilliant, I know where to go now. But here's the thing. Knowing where someone lives doesn't mean you can just barge through the front door. You have to knock. You have to introduce yourself. You have to follow the rules. And that's exactly what HTTP is. It's the set of rules your browser and the server follow when they talk to each other. It's basically a very polite, very fast conversation, like British people at their absolute peak, structured, orderly, and slightly passive-aggressive. By the end of this video, you'll understand exactly what your browser says, what the server says back, and why those weird numbers like 404 and 500 keep showing up. Let's get into it. HTTP stands for Hypertext Transfer Protocol, which sounds like something invented specifically to make beginners fall asleep. So, let's translate it. Hypertext originally meant web pages. Transfer means send. Protocol means rules. So, HTTP basically means rules for sending things across the web. And those things could be web pages, images, CSS files, JavaScript files, JSON data, videos, or API responses. Every time you visit a website, your browser sends an HTTP request to a server. Then, the server sends back an HTTP response. That is the basic conversation. A request goes out, a response comes back, like texting someone who actually replies. Rare, but beautiful. And the beautiful thing about HTTP is that it's completely standardized. Every browser, every server, every device in the world follows the same rules. Your phone in Bristol talks to a server in Tokyo using the exact same format. It's like if everyone on Earth agreed on one language for ordering food. Chaos eliminated. When your browser sends a request, it's not just saying, give me the website. It's sending a structured message with a very specific parts. Think of it like filling out a form at the post office. Except the form takes milliseconds and nobody sighs at you. First, there is the method. The method tells the server what you want to do. Think of it like choosing the action before sending the message. Are we reading something? Are we creating something? Are we updating something? Or are we deleting something? The 4 common methods you'll see all the time are get, post, put, and delete. Let's go through them quickly. The most common one is get. Get means, can you give me this data? When you type a URL into your browser and hit enter, your browser usually sends a GET request. For example, get API users 42. This is basically saying, server, can you send me the details for user number 42? Get is used to fetch or read data. It should not create, update, or delete anything. Get is like looking at the menu. You are just asking to see what exists. You are not ordering yet. Next, we have post. Post means I am sending you some data. You use post when you submit a form, create an account, add a comment, upload something, or log in. For example, post API users. This is basically saying, server, here is some information. Please create a new user. And this is where the request body becomes important. A post request usually sends extra data in the body. For example, name Alex, role developer. So the client sends that data to the server, and the server may create a new record. Post is like handling your order to the waiter. Get says, can I see the menu? Post says, here is my order. Please do something with it. Then we have put. Put is used to update or replace existing data. For example, put API users 101. This is basically saying, server, please update the user with ID 101. A put request also usually sends data in the body. For example, name Alex, role senior developer. So the user finds user 101 and updates that record with the new information. Post creates something new. Put updates something that already exists. It is like editing your profile later because your old bio said future coding legend. And now you want something slightly less dramatic. And finally, there is delete. Delete means exactly what it sounds like. For example, delete API users 101. This is basically saying, server, please remove the user with ID 101. Delete targets a specific resource and asks the server to remove it. It is not read-only. It changes something on the server. So, use it carefully. Delete is not the just checking button. Delete is the are you very sure button. So, the quick cheat sheet is get reads data. Post creates or sends data. Put updates existing data. And delete removes the data. Tiny words, big responsibilities. Next, there are headers. These are extra bits of information about the request. Who's sending it? What language they want the response in? What format they accept? It's like the metadata of the conversation. The user agent header is my favorite. It tells the server what browser you are using. And if you ever actually look at a real user agent string, it's absolute chaos. It will say something like Mozilla 5.0 compatible Chrome Safari like Gecko. It's like a CV that lists every job you have ever pretended to have. There is a whole hilarious history behind why it looks like that. But we will save that rabbit hole for another day. And finally, some requests have body. GET requests usually don't. You are just asking for something. But POST requests do, because you're sending data. Like when you type your email and password into a login form, that data goes in the body of a POST request. The server gets your request, process it, and send back a response. And the most important part of every response is the status code, a 3-digit number that tells you exactly what happened. You have probably seen some of these before without knowing what they mean. Let me give you the cheat sheet. 200 means, okay, everything worked. Here's your page. This is the one you want to see. This is the your food is ready of the internet. 301 means move permanently. The page has moved to a new address. The server is basically saying, I don't live here anymore, but here's my new address. Like when your mate moves to Manchester and keeps redirecting your post. 404 means not found, the most famous status code in the world. The server is saying, I have no idea what you're asking for. It's like knocking on a door and the person inside going, who? Never heard of them. Wrong house. And then there is 500, internal server error. This is the server's way of saying, I broke. I don't know why. I'm having a bad day. Please don't judge me. It's not your fault when you see this. The server is just having a crisis. After the status code, the response also has headers and a body. And the body is the actual content. The HTML, the CSS, the images, the stuff that becomes the website you see. Now, regular HTTP has one massive problem. The conversation between your browser and the server is completely open. Anyone sitting between you and the server, like someone on the same cafe Wi-Fi, can read everything. Your passwords, your messages, your embarrassing search history, all of it, in plain text. That's where HTTPS comes in. The S stands for secure, and what it does is encrypt the conversation. It's like putting the letter in a locked box that only the browser and the server have the key to. The nosy person in the middle just sees the gibberish. We will go deep into encryption in episode 4. But for now, just know this. If a website doesn't have that little padlock in the address bar, your data is being sent naked across the internet. And nobody wants that. Every serious website today uses HTTPS. If you are ever on a site that's still using plain HTTP, your browser will literally warn you. Chrome puts up a big not secure label. It's the internet's equivalent of a red flag. And unlike dating, you should actually listen to this one. So that's HTTP in theory. But let me show you a real HTTP conversation happening live right now. I'm going to open Chrome DevTools. You can do this on any website by pressing F12 or right-clicking and selecting Inspect. Go to the Network tab. Now, watch what happens when I load a page. Look at that. Every single line here is a separate HTTP request. The HTML page, the CSS style sheet, the JavaScript files, every image, every font. Your browser didn't make one request. It made dozens, sometimes hundreds. One web page is actually a whole shopping list of requests. Click on any of these and you can see the full conversation. The request headers your browser sent. The response headers the server sent back. The status code. There's our friend 200. And the actual content. Every website you have ever visited, this is what was happening behind the scenes. Your browser having a rapid-fire conversation with the server, fetching everything it needs piece by piece, assembling it all into the page you see. So, HTTP is the language your browser and server speak. Your browser sends requests with the methods like GET and POST, and the server responds with status codes and content. HTTPS encrypts the whole conversation so nobody can eavesdrop. But here's something we haven't talked about yet. When your browser sends a request, how does that data actually travel across the internet? How does a message get from your laptop in your living room to a server in California? It doesn't teleport. It takes a journey. And that journey involves packets, routers, and a system that's basically a postal service on steroids. That's next episode. And that's HTTP sorted. If you learned something new, do me a favor. Smash that like button. Share this with someone who would find it useful. And subscribe so you don't miss the next one. I'm Mrs.Compile and I'll see you in the next one.